Hello everyone, this is Hoda Ganji. In this video, we're gonna work on an optimization problem. So the problem is easy. We have 14 workspaces in an office. We're gonna consider the location of the printer within this larger rectangle that I have in light gray in a way that is gonna avoid the obstacles, right? You can consider similar situations, similar problems too. For instance, these could be houses and we are looking for the optimum place for the bus stop in a way that it has shortest total path lengths to all the houses. So I'm gonna first consider a point for each of the workspaces. So we can consider that the point is representing the workspace. So I'm gonna go with the drop down menu. I'm gonna go with some points here. I wanna go with my OSNAPs here. Project OSNAP is on, mid OSNAP is on, and I wanna draw one point on the front of each of workspace and on the center of it. So we're gonna have 14 in total because we have 14 workspaces in this office model. I want to open Grasshopper for the rest of it. I'm going to use Grasshopper and Galapagos in Grasshopper. So first I'm going to construct a point using a vector construct point. This point is going to represent the location of the printer. If that is 0, 0, the x of the printer is going to be between 2 over there till 13. So I want to bring a number slider and I want to say let's 2.00. I'm going to connect it to x. Now it goes less than 2 and so on, right? So I need to go back to the settings of the number slider. For minimum, it should be 2, maximum 13. So we guarantee that no matter how we move this, the x of it is within the range. I'm going to copy and paste the same number slider, go to the y coordinate. For the y coordinate is between 2, 3, 4, 5, 6, 7, 8, 9 and a half. So I want to change the maximum to 9.5. Okay, now no matter how you move the sliders, the printer is always going to be within that larger rectangle. I want to add a scribble. Double click here, go with a scribble, and I want to say this is the location of printer or printers, and I want to group these items. On the other hand, we're gonna need to read those points here. So I want to go with params point, and I want to select all the points at once using a standard cascade of select all the points. Right click, set multiple points, right click, internalize the data, and you can erase them in Rhino. If you want, you can go back and erase them in Rhino. So this set of points, if I bring a scribble, this is showing the location of workspaces. That's what it is. And I'm going to group this. Just to have a better visualization, if I draw a line between the 2 points, currently the lines show how people should move to get to the printer, right? So even if we get the best location around here, you see that some of the workspaces like number 1, number 11, number 6 here, and number 9 and 10, they're going through the obstacles. We want to avoid it, right? So when you want to avoid that, that person from like workspace number 6, it cannot go direct. It needs a little bit of a curve here, right? So that's why I want to divide this line, divide curve into a number of points. So each time we're gonna move some of the points in a way that is gonna go around it right? In this case, instead of 10 points, just to make the problem a little bit easier to solve, instead of 10, I'll go with 5, right? So if you consider any of the points right now, it's divided by 5 counts, which is gonna give us 6 points. 1, 2, 3, 4, 5, and 6. So I'm gonna bring another scribble here, and actually here, and what we have here is the divided lines, divided passes. Let's make a group here. So these points need to move, the ones in between, right? The first point and the last point of each of the divided points should not move. It's only point number 1, 2, 3, and 4 that move, the ones in between. So I want to move these points, yes, so I'm going to use the move command. Points go to geometry. First, I'm going to move them along the x-axis to right and left. Then I will allow it to move around, along the y-axis as well. So to the motion, I want to assign x, unit x. Right now, it moved each of the point by 1 meter to the right. As I said, I want the first and the last one not to move. To the factor, we need to assign the value of movement. So I'm going to bring one panel, put 0 in it. This is what's going to be assigned to the first point for each of the lines. I'm going to copy and paste it. So this is going to be for the last one. For the points in between, this one, second, third, and fourth, I want to bring under utilities a gene pool. A gene pool is like having several number sliders at once. I want to double click and say I just need it for 4 items, 4 points in between. And here the minimum and maximum is about how much we're going to move. So I want to say move it just from -1 to 1, not much. Based on the dimensions, you need to decide about it. So now each of these is like a number slider. We need to connect all of them to the factor in the order. So first the first one, hold I think is shift, the second one, and then the third one. So see what happens right now. If I change any of the number sliders, the second, third, and fourth point change, but the first and last one would not, right? So so far what we have here, I want to add a scribble, so keep it organized. If I bring a scribble, we have movement along the x-axis. And I want to group these items. I also, in some cases, when I allow them to move up or down instead of right and left. By the way, let's hide the previous node so you see just the outcome. You can also hide the lines. Basically, we just have points right now. So I want to bring another move. I want to allow the moved points to also move along the y-axis. So this time the motion is going to be y, unit y. The factor is the same, so the first point is not going to move, and the rest of them are going to move by a value between -1 to 1. So I want to select these 3, holding shift, Control C, Control V, bring it here, and connect these in the right order. First the first one, shift, the second one, shift, the last one. So this part here is movement along the y-axis. Bring a scribble. This is movement along the y. Okay, so I want to make a group here. Create a group. I want to hide the previous points, right? Now you see what we got at the end is just a set of points, right? In order to create a path, I need to connect these moved points. So how? I want to go with curve. I think under spline, interpolate type of a line is gonna be okay. So I want to assign the points to the vertices, and it's gonna draw kind of a path to connect the points. Feel free to hide the previous node so we just see the lines. So this is now the pathways. Based on how these values change, it's gonna make curved shape to avoid the intersection with the obstacles, right? But first it needs to know the obstacles. So let's just group this last node by itself. What we have here is the curved path for each of the workstations, right? So I want to group it. I also need to know the obstacles. So I want to read them under params, read them as curves. Select the three obstacles, hold shift, right click, set multiple curves, right click, internalize data. Okay, now what's here, if I bring another scribble, this is the obstacle curves as curves, right? Okay, so I want to group this. So this group is the obstacles, this group is the path. We want to avoid the intersection, so first we need to get the intersections. So under intersect physical, I want to check a curve intersection between these curves and these curves. And the points that you see now, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is basically the intersections. Even right now, if you want, you can move these number sliders, the gene pool, in a way that we try to avoid them, right? But basically I want to ask Galapagos to do that. So we have the points. What about the points? They should become 0 points. So first I need to know how many points we have. In order to get that, you need to get the length of a list. List length is what gives you the value, if I bring a panel, of how many items you have in a list, right? And here I just want to know how many. It put them in a list inside the list, so I can flatten the length here. Now you see that it's giving me how many points there are. One other thing I want to do is that I want to get mass addition. So it's gonna add all the number of the points and then let me know how many it's gonna be. In this case, I have 10 intersections. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 10 eventually should become 0, right? So what I got here so far, if I make a group, I'll bring a scribble. What I have here is the number of intersections. This one to be 0. It must be 0. And I want to create a group here. So this number 10 should eventually be 0. Now on the other hand, the curves that I have over there, I need to know the lengths of them, the actual lengths. So I want to get the length of the curves. And I want to know the total length so I can minimize it. So I'll go with mass addition. Mass addition is like sigma in Greek letters. It adds all the values inside the list. And see the result. It's basically telling me the values in meters because the unit of the file was in meters. So from workspace 1, the first one should move by 8 meters, second one by 6 meters, and so on. And again, I want to flatten this so it's not a list in a list. So I want to flatten the result, right? And I need one more, mass addition, because I want to know the total length of all the passes. And if I connect it to a panel, it's telling me that the total value is now 81. So we want to minimize that number. I want to bring a scribble here. What we have here is the total path length and to be minimized. This one cannot be 0, it can only be minimized. So I want to group this, create a group. So what we got so far, we got 10 intersection points which need to be 0. If these points on the workstations is distracting, you can go and hide them. Right click hide, turn the preview off. I just want to see the intersection points, which are now 10. Those 10 should become 0 eventually, and that result should be minimum over there. What I want to do eventually is that under utilities I want to bring Galapagos. Galapagos is the optimizer in Grasshopper. You can connect one item to the fitness. I have two items here. This result here should be minimum. This mass addition should be 0. Right now, if I connect this to the fitness, let's say if I add the two numbers connected to the fitness, it's gonna like this. If I go with addition, connect this result and this result, let's see it in a panel. What happened here? It went with 81 plus 10 points, which is 91. Right now, if I connect fitness to this, it's gonna minimize this, but because the two numbers are within the same range, maybe there would still be 5 or 6 intersections that it's gonna still consider. In order to prioritize the intersections which are going to be 0, I want to add a lot of weight to this one. So I want to multiply this number, 10 intersections, by a very large number and then assign it to addition. So I'm going to go with a multiplication. The result here, I want to multiply it by a very large number, let's say 1000. Okay, and what goes to the addition is this one. So now this value is now 10,081. The optimum range that we are looking for is about 81, and because this 10,000 is a very huge number, it's gonna prioritize this one. It's gonna get rid of the intersections. Each intersection is gonna cost 1000 till it's gonna be 0 here and the minimum value over there. So this is what we're gonna minimize. So fitness goes to results. What are the genomes? The genomes are the number sliders that we assign, which is gonna affect the output, right? So for instance, the X and Y number sliders are our genome. So I wanna connect genome to the number slider that goes to X, hold shift. Genome goes to the number slider that goes to Y. Also, I don't know how much movement I need in the gene pool. So I want to connect genome to the gene pool number 1, genome to the gene pool number 2. So that's my 4 connections to 2 number sliders there, 2 gene pools, which is basically like 4 number sliders here, 4 here, and 2 there. It's kind of like I'm asking for permutations through 10 number sliders to get the best fitness. Next, I want to double click on the Galapagos node. Make sure that you change the fitness to minimize. That's what we want. Minimize, right? And under solvers, I'm just going to go ahead and start solver, and then you're going to see that it's going to try very different numbers. Right now, it was able to decrease it to 4 number of points. And it's trying to make it better and better. So it makes some guesses. See that this number, for instance, what was 8,000. By trying different values, it's trying to minimize it. So it was able to minimize it to 2,000 and something, which means we still have 2 obstacles over there. So it's going to jump between different values. You see it's converging to an answer. And for now, we are sure that at least it's gonna, at best, it's gonna still have two intersections, which we're still gonna get rid of. So we have two solutions. We can let this run for a while, but if you let it run for a while, let's say by for a while I mean for half an hour, you let it run, it will probably find the answer. But if it doesn't find the answer, stop the solver, hit OK. Let's have some human interaction. I want to help it a little bit. So far, it was able to avoid obstacle number 1 and 2. For this one, I want to see which of these number sliders is going to help to avoid it. So I want to change these number sliders a little bit in a way that it's going to be easier to solve it. So I'm going to change this a little bit here, right? And then I'm going to solve it again. So I'll go with the Galapagos. It's still on minimize solver, start solver. So I intentionally moved the 2 points to the other side because I wanted to change the situation here so it would try it differently. Now again, it's gonna what it's doing is that it's guessing numbers between all the 10 number sliders that we assign to the genome to get the best number. Now it knows that it's gonna have either two intersections over there or two over here. If we let it run for a while, it will probably be able to avoid each of the two. So I'm gonna give it some time. And again, if it doesn't work, it will eventually work. It will eventually find a number less than 2000, but I'm gonna stop the solver, okay, and I'm gonna help it a little bit with the number sliders. Maybe if I move the X and Y of the printer a little bit further on that direction, it's gonna be able to solve it better. So now I kind of helped it. So right now, if you look, it's gonna have 0 intersections here, and the value is about 89. So I'm sure that it has no intersections here. Now I want to run it again, and I want to see if it's gonna be able to reduce that 89 meters by a few meters. So I'm gonna go to solver, start solver. It's gonna try different numbers, but this time I'm sure that it's not gonna be up to 1000 because the start value that it started from was actually 89. So now it's trying 89. It's going to try other numbers in a way that this 89 is going to be minimized. So I'm going to give it some time. Each of these lines is a solution that it's running. Here it seems that it was able to reduce 89 to 85 and reduce 85 to 84. So I'm gonna let it run a little bit. I think probably about 83 or 82 is the minimum number that it can go with, around 83. So now this solution is already acceptable to me. I can let it run a little bit further, but otherwise, if it's all good, you can stop the solver, hit OK. So now the intersections are 0. The minimum amount of total pathways to the printer is 83 meters, and we got kind of a best location to be here. You can think of similar examples, for instance, we want to have the shortest total path to the exits, to the egress. We might want to design a hospital in a neighborhood or a school in a way that it has the shortest total path to the neighborhood residential areas. So you can see that this situation is a common situation, and this is one of the ways to solve it. So I'm gonna just maximize my screen here so you see the whole script. That's it for this video. Thank you so much. Please like and subscribe for more videos.